Assalamu alaikum and very good morning dear students. This is our video lesson 9 and this is for chapter 5 Exponents and Radicals. Today's topics are Laws of Indices, numbers with rational exponents, surds and operations with exponents and radicals. Dear students, please open your mathematics books, new countdown, book 8. By the end of this lesson, you should be able to identify and implement 6 laws of indices. Determine numbers with rational exponents, identify and express surds and its types, apply 4 operations on exponents and radicals. Now, exponents. You people have done exponents in your earlier classes, but you learn indices. We call exponents as indices or powers. I want to revise this, that exponential form is 5 cube. Like any number with a power is called exponential form. It can be 3 square, it can be 10 power 4. So this is exponential form. And in word form we can write 5 to the third power. And in expanded form, this one will be equals to 5 multiplied by 5 by 5 because it is 3 here, so you multiply 5 thrice. And its standard form or the value of 5 cube is 125. Now the laws of exponents. The first law of exponents or indices is multiplying powers with same base. When we have same base and we have to multiply, we will add powers as a power m multiplied by a power n is equals to a power m plus n. Similarly, a upon b whole power m multiplied by a upon b whole power n is equals to a upon b whole power m plus n. Dividing powers with the same base, so this is opposite. In division sum we will subtract powers. So a power m divided by a power n is equals to a power m minus n. Now power of power, which is a power m power n. So we will multiply powers in this case. So it is equals to a power mn. Now multiplying powers with the same exponents. If the base is different but the exponent is same, we have to multiply base and write power once or exponent once. So a multiplied by b is ab and the power is m or exponent is m. Negative exponents. If exponent has negative sign, the numerator will be denominator and it will be with positive sign, like a power minus m is equals to 1 upon a power m. Negative has become positive. Same as if the negative sign of exponent is with denominator, it will be numerator with positive sign. Now power with exponent 0. This is very interesting rule. A power 0 is equals to 1. And interestingly, 100 power 0 is also equals to 1. 1000 power 0 is equals to 1. X power 0 is equals to 1. So it means any variable or any number with power 0 is equals to 1. Now the examples of laws of exponents. The examples are 4 square multiplied by 4 cube. Same base and exponents are different. In multiplication sum, so we will add up exponents. So it is 4 power 2 plus 3 is 5. So it is 1024. This is the answer is, or its standard form is 1024. 5 power 4 divided by 5 square. So 4 minus 2 is equals to 2 or square and the standard form is 25. Now 3 power cube power square. So we will multiply powers here. So 3 multiplied by 2 is 6. So 3 power 6 is equals to 729, which is the standard form. Now 5 square multiplied by 3 square. Same exponents but different base. We will multiply base and write exponent once. So 5 by 3 is 15 square. So it is equals to 225, which is standard form. Now 4 power minus 3 is equals to 1 upon 4 cube, which is equals to 1 over 64, which is standard form. Now 6 power 0 is exactly, it is equals to 1. Now rational numbers in radical form. If a power n is equals to b, the number a is called nth root of b and is written as a is equals to b radical form of order n. For example, 2 in radical form of order 3. So what we have to write, 2 cube, which is equals to 8, and we will write 8 radical form of order 3, which is same as 2. So this is 2 in radical form of order 3. Now 5 in radical form of order 4. So 5 power 4, which is 625. So 625 radical form of order 4 is equals to 5. Now more examples. The example is 3 216. So what we have to do, we will convert this in cube form because cube is here or 3 is here. So it is 6 power 3. Now both the 3's will be cancelled. Like order 3 and exponent 3, both will be cancelled. So it is equals to 6. So same as here. This is 2401 radical form of order 4. If we will convert this as 7 power 4, so both the 4's will be cancelled and the answer is 7. And it is under root 81. Nothing is written here. It means what is written over here? Yes, 2. We don't write 2 here when it is square root. So this is 9 square, which is same as 81. And so 2 will be cancelled by 2 and 9 is the answer. Now surds, this is a new concept for you. The radicals like under root 2, under root 5, under cube root 7 and etc. cannot be reduced to rational numbers. They do not give a terminating or a non-terminating recurring decimal. These radicals are irrational and are called surds. So when we solve these, the answer will be irrational and these are called surds. Radical of the form a radical form of order n which cannot be reduced to a rational number is called a surd of order n. As I just told you, if the answer is irrational, we call it surd. The example of surd are under root 2 is equals to 1.4142 and so on. Like more numbers will come, but this is non-terminating and even not recurring decimal. So this is irrational. And so this surd is surd of order 2 because it is a square root, so order 2. Now 11 radical form of order 3 is equals to 2.223. So this is surd of order 3 because this decimal form is irrational. So this is surd of order 3 because 3 is here. Now some surds are type A, B radical form of order n, where A is rational and B radical form of order n is irrational. So it means both types of term are here, like rational and irrational also. So these surds are known as mixed surds because irrational and rational, both type of numbers are present in this term. Two surds are similar if their irrational parts are same, as 4 2 radical form of order 3 and 5 2 radical form of order 3. So 4 is rational part and irrational part is same in both the cases. So these are similar surds. So if irrational part of surds is not same, they are dissimilar, as 5 2 radical form of order 3 and 3 2 radical form of order 4. So both the irrational parts are different. So it means these surds are dissimilar. Now exponents and radicals. A few more points about these. So the index of radical becomes the denominator of the rational power. The index is over here. And the exponent of the radicand is expression inside the radical. So x cube is radicand over here, becomes the numerator. So how it will be written? This is 3 is numerator and 2 is over here is denominator. And in second example, this is 3 here and power is 9 or exponent is 9. So it is a power 9 over 3, which will be equals to 3. Now here 5 and then 2 power 10. So 10 will be numerator and this 5 is denominator. When we will simplify it, it will be square or 2. So this is 2 square, so it is equals to 4. So the rule is written as root then x power, which is same as x power upon root, power upon root. Now operations with exponents and radicals. Any rational number may be expressed in the form of a radical using the rule a is equals to a power n, radical order of n. Then 2 is equals to under root 2 square. So the value is same. This square will be cancelled by this square, so it is equals to 2. So we can write 2 in form of under root 4. So this is explanation. You don't have to write this in question, but you can understand with the help of this that 2 square multiplied by 1 over 2, as we just learned that numerator and denominator thing. So this is equals to 1. So 2 is, this will remain 2, which is equals to this. Here 3 over 3, which will be equals to 2. So we can write 2 power 3, which is 8, and this is order 3 of radical form. So this is same as 2. Same over here, 2 is equals to 2 power 4 of radical form of order 4. So 2 power 4 is 16. So 16 radical form of order 4 is same as 2. So and so on. We can write any numbers like this, which will help us in solving sums. Now the sum or difference of two similar surds can be calculated by the rule a b radical form plus minus c then b radical form. See this surd part or irrational part is same. So what we have to do, a plus or minus c, we'll write it, and then this common surd we will write once. So now here this is the rule. Now this is example 4 11 radical form of order 3 plus 5 11 radical form of order 3. Same surds. So 4 plus 5 we will do, which is 9, and then 11 radical form of order 3 we will write it once. So this is the answer. Now in subtraction, 5 3 radical form of order 2, because nothing is here, so it means 2 is here, minus 3 3 radical form of order 2. So 5 minus 3 is 2, and then 3 radical form of order 2 is the answer. Now more operations with exponents and radicals. A part of a number under a radical sign can be taken out as, like this is 24 radical form of order 3. So we can break 24 in this form, 8 multiplied by 3. Why we have changed it in 8? Because 8 is equals to 2 power 3. So this will be cancelled. This can be cancelled 3 by 3. So it will remain 2, which will be out of the it will be solved. So 2 is rational part and 3 radical form of order 3. So this is the answer of 24 radical form of order 3 is equals to 3 radical form of order 3. I hope this is clear. So now 75. Again we can break it in this form. 25 multiplied by 3, and 25 is equals to 5 square. So this square can be cancelled as this one, and this is 3 radical form of order 2. So 5 3 radical form of order 2 is the answer of 75 radical form of order 2. The rational part of a mixed surd can be introduced under the radical sign, or you can say the reverse of this. You can see this is the answer which is written as question, and this is the question which is written as answer. So this is reverse process. So if the number is given 2 3 radical form of order 3, we can convert it in this way, like this 2 will be changed as this radical form. So 2 cube radical form of order 3, this is same as 2. So we have written this in this form. So both have same radical form. So we can solve it. 2 power cube is 8. So 8 multiplied by 3 is 24, and radical form of power 3 or order 3. So it is same as this. Now another example, this is multiplication. So here 4 multiplied by 2, which are rational parts. So we will do 4 multiplied by 2, which is 8. Then inside is 8 multiplied by 2. So we will do it. So this is 8 multiplied by 16, radical form of order 2. We can convert it 4 square, radical form of order 2, same as 16. So now this can come out of the radical sign because 2 is cancelled by 2. So 8 multiplied by 4 is equals to 32. And 32 is the answer of this question. Now the same question with division sign. So 4 divided by 2 instead of multiplication. So it is equals to 2. And here 8 multiplied by 2, we will write here 8 divided by 2. So it will be equals to 4. So 2 multiplied by 4 of radical form order 2 is equals to 2 multiplied by 2 square. So this square will be cancelled by this. So 2 multiplied by 2 is equals to 4 is the answer. I hope this is clear to all of you, but I think you need more practice in these type of sums. Now the summary of today's lesson. We learned 6 laws of indices, numbers with rational exponents, surds and its types, and 4 operations on exponents and radicals. Now written assignments are, your task 1 is question number 1 and 2, exercise 5, page 65 of new countdown 8. Your task 2 is question number 3 and 4, exercise 5, page 65 of new countdown 8. Your task 3 is question number 5, exercise 5, page 66 of new countdown 8. Your task 4 is question number 6, exercise 5, page 66 of new countdown 8. And your last task is question number 1 to 5, MCQs 5, page 66 of new countdown 8. I hope you enjoyed today's lesson. You learned a lot of new things today. Allah Hafiz and keep practicing.